Okay, class. Hey, good morning. It's a snow day, so we have to, we're losing a day today, and plus I'm going to be gone on Friday, so we have to make up some time here. So on this video lecture, we're going to discuss tangential velocity, omega, which is angular speed or angular velocity, radians, degrees, and RPMs. Okay, so take a look at a circle here real quick. And let's go ahead and make this here. Okay. So there's a circle, and we'll assume that this is the radius here, or the center of the circle. And this here, we'll call this here the radius r. And there is some object here with a mass, we call mass m, and it is traveling in this direction here, like so. Now, after some specified time, the object is here at a new location. Okay? And during this time here, it transversed some angular measure or some displacement here, delta theta. And this here, we can call this here the arc length, here. Okay? From here to here is what we call the arc length, and is given the formula r times delta theta is the arc length. Okay, now, taking a look at this, this object here, if it goes all the way around, that's the circumference, okay? So if I wanted to find the speed of the ball as it goes all the way around, we could say that velocity tangential is equal to, the distance would be 2 pi r divided by t, which is the period. So the time it takes to go all the way around is the period t. And we can express tangential velocity as 2 pi r divided by the period. Now, taking a look at this situation here, suppose I wanted to find the speed from here to here. Okay, this location, or from here to here, in some time little t. So what we could say is that velocity could also be expressed, velocity from here to here, tangential, could be given as s over little t like this, speed from here to here. And we make a substitution here into here, and what we get is that I get r delta theta over t. Now, this is the non-calculus version, because if we're in calculus class, we'd be doing the chain rule and some other stuff, but we'll go ahead and skip that. Now, if I look here, look at this here, this is the rate at which theta is changing with time, and that's called omega. Okay, omega. So tangential velocity equals r times omega, okay, where r is the radius and omega is the angular speed, okay, and omega means the rate at which theta is changing with respect to time, t here, okay, that is called omega. So tangential velocity really, this is constant, but radius can change. So if you have, because we have some circles here, like this is maybe R1, and this here is, let's say, R2, right here, right? And this object is moving this way, this object is moving this way, and we'll call this position 1, position 2. Which one of these would have a greater tangential velocity? So if I do V1, it's going to equal R1 times omega. V2 will be R2 times omega. So therefore, this is greater because omega is constant. The rate at which theta changes is the same for both of these. However, tangential velocity is greater because the radius is greater. That's why, like in a track meet, people who are on the inside lane have the advantage because they have a greater, shorter distance to cover. All right, so now that's where omega comes from, and tangential velocity here, okay? Now, radians, okay? So radians is talking about some different kind of measure. And what we know is that, so delta theta is what we call, is equal to 2 pi radians. Okay, radians here, like that. So once around the circle, so delta theta, to go all the way around, would equal 2 pi r. That's once around, okay? And so what happens is that 2 pi r is also equal to 360 degrees. That's to go all the way around, okay? So 2 pi r is to go all the way around. Okay, this is, hold on, 2 pi radians equals 360 degrees is also equal to 1 revolution. Okay, so this is something that we want to be able to memorize here or understand. Or we could also say pi radians is equal to 180 degrees, which is equal to half a revolution. Okay. So these is what we need to understand, this relationship here, to help us negotiate certain, certain things that we have to get our answers in, whether they want revolutions per minute, degrees, or we want in radians. Okay, thank you.